Alright, let's get started with the properties of trapezoids and kites, plus just a little strategy for identifying quadrilaterals in section 7.5. Our objectives are to use properties of trapezoids, use the trapezoid mid-segment theorem to find distances, use the properties of kites, identify quadrilaterals, and our essential question is, what are the properties of trapezoids and kites? Alright, so let's get some vocabulary and implied statements down. We have our trapezoid. It is a quadrilateral with exactly one pair of parallel sides, so our implied states a trapezoid implies a quadrilateral shortened to quad with exactly one pair shortened down to PR, so pair of opposite sides, and then our parallel symbol. Here's a picture. It has four sides. The sides that are parallel are called bases. Then the other sides are called legs. And at each base, you've got angles, it's called base angles. So base 1 would have base 1 angles, and then you have base 2 angles. And they are base angles when they are consecutive and sharing the same base. Next, let's look at their properties, properties of an isosceles trapezoid. So if a trapezoid is isosceles, then the following statements are true. The legs are congruent, so you can see that each side legs are the same length. So isosceles trapezoid implies legs congruent. Each pair of base angles are congruent. So these two are congruent, and then these two are congruent. And then the diagonals are congruent. All right, let's take a look at this example where we want to find the missing angles. We can see the two tick marks on each leg, matching tick marks, therefore it's isosceles, which means that the angles are congruent at the base. We know that if this one is 50 degrees, then this one must also be 50 degrees. All right, next we want to look at the other base angles, and we know that since we have parallel lines, we can highlight a C shape, and remember that consecutive interior angles formed by parallel lines cut by a transversal, so we have parallel lines cut by a transversal, we've got a C shape, consecutive angles, so they're on the same side of the transversal and on the inside of the parallel lines, implies supplementary angles. So that makes these two angles add up to 180 degrees. So if we subtract 50 from 180, we get 130 degrees. And since these are the same base angles, then they are congruent. So our theorem is, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So it's the converse. All right, our first example in the coordinate plane, we want to show that ORST is a trapezoid. Then decide whether it is isosceles. To start, we want to compare the slopes of opposite sides. So find the slope of RS and the slope of OT. We find that they are both the same 1/2. This means the slopes of RS and side OT are the same, therefore the sides are parallel. Then we figure out the slope of ST and the slope of RO. They are -1 and undefined. So since the slopes are not the same, ST is not parallel to OR. And since ORST has exactly one pair of parallel sides, it is a trapezoid. For step 2, we want to compare the lengths of the legs, and this is to verify whether it's isosceles. So the length of RO, which is a vertical segment, and those are really easy to figure out lengths because you just count along that vertical segment, so you get a 3, count of 3. But for ST, it's going diagonally, so you have to use the distance formula. So we plug in the numbers for x, y of each end point into the formula, and we get square root of 8, which simplifies to 2 square root of 2. So these are not equal lengths, therefore it is not an isosceles. So quadrilateral ORST is not an isosceles trapezoid. Next, let's look at the stone above the arch in the diagram. Is it an isosceles trapezoid? Sorry, it is an isosceles trapezoid. So find the measure of angle K, M, and J. Step 1, we would find the measure of angle K, because since it's an isosceles trapezoid, K and L are congruent base angles. Therefore, measure of angle K is 85 degrees. Step 2, find the measure of angle M. Because the measure of angle L and M are consecutive interior angles formed by angle LM, side LM intersecting the two parallel lines, so a transversal, they are supplementary. So we subtract 85 from 180, and the resultant measure of angle M is 95 degrees. And our third and final step is to find the measure of angle J. Because angle J and angle M are a pair of base angles, they are congruent. Therefore, measure of angle J is 95 degrees. So this is 3 steps to find all 3 missing angles. Alright, next we have the definition of a mid-segment of a trapezoid. It connects the midpoints of legs and is parallel to the base. So here's the leg 1, leg 2. So the midpoint, which is E, midpoint, which is F, connect the midpoints, and this is called a mid-segment. It is middle-ish, and it is parallel to the bases. And its property is that a mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if I want the mid-segment, I add the 2 bases, take half, and that will be the length of the mid-segment. So aka the average of the bases, so EF is the mid-segment of trapezoid ABCD in this image. So the length of EF, the mid-segment, is half of AB plus DC. So let's take a look at this example. We're going to find the value of X. So 7 is the length of the mid-segment, one base is 10, and the other base is 2x. Since the mid-segment is half of the sum of the bases, we use that formula and plug in our value. So we have 7 equals 1/2 of 2x plus 10. Next, you can solve for x, so half of 2x is 1x, and then half of 10 is 5. Continuing to solve for x, x equals 2. Alright, so let's take a look at an example where we'll use the mid-segment properties to solve for the unknown information. So we're going to find MN. So we set up our mid-segment formula. MN, being the mid-segment, is equal to half of the sum of the bases. So then we substitute our 2 bases, which are 12 and 28. So when we do order of operations, we get that MN is a length of 20 inches. Alright, now let's look at a mid-segment in a coordinate plane. So find the length of y to z. Since y to z, z's kind of hitting in a place that's hard to tell what the coordinate would be. Y is a little bit easier, but z is difficult. But we can get the length of SV and the length of TU, add them together, take half of that, and that'll get us y to z. So first get the length of S to V. So using distance formula, you get a length of SV, 2 square root of 5, and the length of TU is 4 square root of 5. Next, you use the mid-segment formula and set up an equation, plugging in your 2 lengths, and then do order of operations, and it comes out to be 3 square root of 5. You can also give it as a decimal value. Alright, our final quadrilateral shape to look at is our kite. It's a quadrilateral with 2 pairs of consecutive congruent sides. So we obviously have an implied statement. So note these following statements. Horizontal diagonal cuts the kite into 2 isosceles triangles. Alright, things to note. Horizontal diagonal cuts the kite into 2 isosceles triangles. The vertical diagonal cuts the kite into 2 congruent triangles, and the diagonal between the isosceles triangles is bisected. So here we have horizontal cuts the kite into 2 isosceles triangles, and the vertical cuts the kite into 2 congruent triangles. The diagonals between the isosceles triangles is bisected. That's here. Alright, and then we have if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent, as shown here. Exactly 1 pair of opposite angles are bisected, as shown here, and diagonals are perpendicular. So based on these properties of kites, see if you can figure out how to find the value of x and y. So pause the video and try to find x, and then try to find y. First, we would look at finding the length of x, which is a side of a right triangle, so Pythagorean theorem can be used here. We know the length of 6 and the length of 8. So we plug in 6 for A and 8 for B, and we're finding out what C is, so we're going to substitute x for C. And so you work it out, order of operations, to undo square, do square root, so x is a length of 10, so this side is 10. And then to find the angle, we know that opposite angles are congruent and the diagonal bisects. But since we have congruent sides, we can say 2y plus 36 equals 76. Solve for y equals 20. All right, so this completes all of the quadrilaterals, and notice that on our chart, the kite is by itself with no properties of any of the special parallelograms, only the properties of a quadrilateral, which means it has 4 sides. That's the only thing that it's like. And then a different part of the branch here is your trapezoid, and then more specifically your isosceles. Again, you can use your true and false to help you identify and answer true-false questions. Go up with your arrow is true, going down with your arrow is false. And this is a great summary chart of all the properties that any of your quadrilaterals will have. It also allows you to see which quadrilaterals have what properties in common. So it's just a great way to study for all the properties in one snapshot. So take a moment to fill in your chart and use this as a study tool. And that's all for this lesson. See you tomorrow.